Howdy folks, you join me here today with a Toyota RAV4 EV. This car is actually a particular specialty of mine. I've worked on hundreds of these cars, maybe even over 1,000. And that's out of only a little over 2,500 of them that were even originally built. This car is in here because it has coolant intrusion into the large drive unit. For those that don't know about these cars, this was built in a partnership between Toyota and Tesla. So it's basically just a regular Toyota, third generation Toyota RAV4 body shell with a Tesla powertrain. And the powertrain that it uses is very similar to the early Model S. It uses a large drive unit. It's been flipped around backwards and is run in reverse rotation. And pretty much all the electronics under the hood are basically identical to that you'd find in a Model S. It's got a Gen 1 Model S onboard charger, DC to DC converter, battery coolant heater. There's only a couple things that are kind of unique on it. The cabin heater is semi-unique, but it's the same that's used in a few other EVs. It's just a kind of a generic Denso unit with a few slight modifications. And the AC compressor is a real common AC compressor for a lot of cars. I think that's also a Denso unit. It's, you know, again, kind of just a generic thing. The battery pack itself, 41.2 kilowatt hour battery pack, again, built by Tesla. Uses very similar module construction to the Model S, but the modules themselves are not the same. It actually uses two different styles of modules in it. There's 6 modules that are 12S, and there's 4 modules that are 5S. So that brings it up to a total of 92 cells in series. And it uses the same cells as the original Tesla Roadster actually did. So they're only a 2,600 milliamp hour 18650. But anyway, that's not what we're here for today. We're here for the drive unit. So this RAV4 has coolant intrusion into the drive unit from a failing rotor coolant seal, which of course is a very common failure for the Tesla large drive unit. And that's, you know, again, one of my specialties. I rebuild a lot of those. And I think this will be my first time actually filming a complete rebuild for a large drive unit. So that should be pretty cool. But anyway, the coolant intrusion in here has started to cause a buildup of corrosion within the stator. So that's the windings that make up the motor. And when the stator starts to get that corrosion in it, it has a bunch of steel bar laminations, and then the rotor itself also has a bunch of steel laminations around the outside of it. And those steel laminations get a buildup of rust from the coolant in there. And as rust forms, it expands, and that expansion actually squeezes the rotor into place in the motor. And it basically just causes a lot of resistance. And as of right now, that's the state that this car is in. So it can still physically move, but it takes a lot of throttle input to get it to move, and it's very jerky at low speed. According to the customer, if you drive it around a little bit, it kind of clears up, which is pretty typical from what I've seen before. But this is one of those problems that gets continually worse, and eventually it'll get to a point where the car won't even be able to move under its own power. I've encountered some of these in the past where, you know, just to get them to move, you have to get the throttle pedal to the floor matted, and sometimes even that won't get them to move. Of course, the big risk is if you get a loss of isolation within the stator or damage to the inverter electronics, which is kind of the worst case scenario, especially for one of these. So the inverter is kind of unique and not really easy to find replacements for. So you want to avoid that at all costs. In this case, I've already checked the isolation on the stator. It's firmly in what I would call the okay range. Not terrible, not great, but it should be recoverable for sure. You know, it's still serviceable and the car still runs. So anyway, at this point, what we're gonna do is we'll go ahead and get everything prepped to pull the drive unit out. So of course, we'll do our high voltage disconnect procedure, and then we'll start pulling the drive unit out of the car, and we'll get it on the stand to rebuild it. All right, so first things first, we're gonna disconnect the negative terminal on our 12-volt battery. That way we don't throw any alerts when we have things apart on the car. Alrighty, so now we're going to remove the high voltage disconnect, which lives under the passenger seat here. So there's just a little flap in the carpet that pulls up. And then there's just a plastic cover down here. There we go, disconnect removed. All right, there's one more thing that we need to do before the car goes up in the air, and that's we've got to remove these 3 bolts right here. Those are 19 millimeter heads, and they hold in the front motor mount structure. So we'll get those out before the car goes up into the air. Alrighty, so we've got the car up in the air, and of course I did take the front wheels off. Next we got to remove these plastic panels. There's 2 side panels like this. They're held in usually with 4 clips. I think we're missing a couple, which is real common on here, but we've got the side panels and of course the bottom cover, which has a handful of screws and some more of those clips. So we'll get that thing pulled off real quick. Alrighty, so we've got those plastic panels removed. Now we need to take off these brackets on either side, and then there's this big bar that goes kind of underneath the motor on the driver's side. But first, before we do that, I actually want to show you guys something. So this speed sensor right here, or rotor encoder sensor would be the proper term, is the easiest way to check for coolant intrusion on a large drive unit. And anybody that has any car that's equipped with one of these motors, whether that's this car, the RAV4 EV, the 2012 through 2017 Mercedes B-Class electric, which is also another Tesla partnership car, or a rear-wheel drive or performance model S or X. All those cars use the large drive unit. And the coolant intrusion issues are just really rampant with these. And the big failure is the seal that's in this housing right here. So there's a seal for the rotor. The rotor has a hollow tube in it, which we'll go more into that when we take the motor apart so that I can show you. But what I want to show first is to remove this speed sensor is pretty simple. Actually, on the RAV4s and the B-Class, you can do it without lifting the car up or taking the wheel off or anything. All you got to do is turn the wheels all the way to the right, and then you can remove the plastic panel in the wheel well here. It's a little bit different on the B-Class, but pretty similar. And then all you have to do is just unplug this sensor like so, and then it's just one bolt that holds it in. So we'll pull that out real quick. And then the sensor just pops right out. And as you can see, this one's got quite a bit of coolant on it from that seal failing. So anyway, on the Model S and Model X, it's a little bit more difficult just because the car's so low and there's not very much clearance. You have to pull the bottom cover off of the car. So really you have to get the car up on ramps or something at a minimum so that you can crawl under it to actually get access. But it's not too bad. I mean, in reality, if you have a set of ramps and some basic hand tools, it shouldn't take more than 10 or 15 minutes at the very most to check it. And of course, if anybody is in the Pacific Northwest or specifically in the Portland area and wants to bring it by the shop, I'll check your speed sensor for free. So yeah, that's easy. But anyway, let's get to the rest of the disassembly process here, and we'll get the bracketry off, and then we can start disassembling everything else that we need to get the motor out. All right, so all this bracketry comes out with just 17mm bolts. Alrighty, so all that bracketry is off now. I'm actually going to clamp off the coolant lines so that we can try to lose as little coolant as possible so that when it goes back together, we don't have to bleed too much air out of the system. Alright, so now the coolant lines are clamped off. We'll go ahead and drain the coolant out of the motor itself. See, now that our line's clamped off there, all of our coolant that's above this in the system will stay in, and we won't have to purge out all that air. It saves a little bit of time. All right, so to keep this one from losing a whole bunch of coolant when we break the other line loose, because there will be kind of an air block in here, I'm just going to shove a towel in that. Now we can take this side off. I'll go ahead and just plug that one off as well so we're not getting dripped on the whole time. And while we're at it draining fluids, let's go ahead and drain the gearbox as well. All right, there's that done. All right, so now we can start removing all of the electrical connections and bracketry and other ancillary stuff. Of course, we already removed the encoder sensor and the coolant nipple here, but there is a little bracket right here that we've got to take off that holds the wiring harness and the coolant line there. On the other side here, we've got all the quote-unquote important bits. So we've got our communication harness to the inverter. Our high voltage cables come in behind this black shield here. There's a little ground strap. And then way back there, I don't know if you can really see it. I think our sway bar end link and stuff might be in the way, but there's a connector for the parking pawl servo motor as well. So we'll unplug all that stuff, remove the bracket. There's another big chunk of plastic that holds the high voltage cables that goes over the top of the motor that's bolted on up here, as well as on a bracket above the gearbox. So we'll go ahead and remove all that stuff. All right, so the rest of the hardware holding on this plastic piece on top of the motor is a little bit difficult to get to, and you can't actually get to any of it with any power tools. Strictly hand tools. So what I've got here is just sort of a little stubby short ratchet to get this one, which is just right above the cables there. Alrighty, so now that all that hardware is loose, we can disconnect our high voltage cables. So just remove the little cover here on the end. That's like a little captive bolt in there. Doesn't come out all the way. And then we just have a couple of 13mm bolts. Since the high voltage disconnect is out and it's actually a physical disconnect that splits the pack in half, in theory there can't be any voltage here, but it's always better to be safe than sorry. And as you can see, we got nothing. So now that those are unbolted, these cables just pull out. They're just kind of a gland with an O-ring in there. If you live in a place where there's a lot of corrosion, these things can get kind of corroded into place. Luckily, we don't have much corrosion where I am. All right, those are off. Now we can move on to taking apart some of the suspension and removing the axles. Alrighty, so now that the axles and everything are all out, the fun part begins. We get to actually drop the motor out. So I'll get our transmission jack into position. And then there's only a few things that have to come apart. We have to take this side mount off, which of course has the bolt that goes through the actual motor mount itself, and then it's got, well, it's supposed to have two bolts here actually, and then the nut here, but it looks like we're actually missing a bolt. This motor has been replaced at some point by the Toyota dealer. Actually, if you look right there, you can see the date that this was probably put together sometime in 2020. So yeah, whenever this got assembled by the Toyota dealer, apparently they missed a bolt. So I'll have to see if I can scrounge up a replacement for that. But we've got the side mount here. This whole front piece comes off. That's actually what we removed the 3 bolts up top under the hood for. So it's just got 4 more bolts holding it in, which, looking at it now, I can tell that they used the wrong bolts in these positions. They're normally a flanged bolt. These are just a non-flanged bolt with a washer. So that's not right. And then the only other thing left is the mount on the back side right there. So it's really just a handful of bolts, and then the whole thing will drop out. So let's get to it. Of course, the drive unit is heavier on the motor side, so I'm going to offset the jack towards that side, since that's really where the weight needs to be supported. I think we've got that position pretty decent. I'll grab a couple straps to attach that to the jack so it doesn't fall off. There we go, all the hardware is out. Should be able to just give this a little tug back. And we're pretty much clear. Bingo, drive unit removed. Alrighty, so we've got our drive unit on the stand here. This is a specially modified engine stand specifically just for putting these large drive units on. It's just basically a clamshell that clamps around the motor portion. Anyways, first things first, we'll get started into tearing this thing apart, and we'll look at the failure mode. So the big failure mode on these large drive units, of course, is a failure of the rotor coolant seal, which is in this little manifold here. So we'll just take this off and take a look at it. There we go. So that's the rotor coolant manifold. And you can see this has got this is what people in the community of rebuilders would call the single lip seal. So pretty much all large drive units built after, say, late 2015, early 2016 have this single lip seal, which is a lot more prone to failure than the earlier triple lip seal. Let me see if I can find one of those to show real quick. So this was our single lip seal housing that we pulled out, and it's a little bit hard to see on camera, but it's got a single lip that's curved inwards into that bore. So a single lip that's curved like that. If we take a look at one that has the triple lip, you can see it kind of has a protrusion that sticks out. So this actually has a lip that curves out like so, and then it actually has two separate sealing lips that curve down like that. So it's got two lips down inside and then a single lip that sticks out this way. And these were a lot less prone to failure, but they do still fail eventually. So now that that's out of the way, looking at the end of the rotor here, I can't see any significant signs of corrosion or anything, but from the seizing behavior, we know that there has to be corrosion going on in the stator. If I try and turn this rotor, you can see I can't get it to budge. That's definitely our problem. Before I pull the end cap here off, though, I'm actually going to pull the inverter off, because usually I like to rotate the motor in this direction first, so that if there is any loose coolant in the motor housing, it won't flow into the inverter cover when we tip the motor that way. So we want to tip it up this way first, remove the inverter, and then we'll tip it back the other way to pull the end cap off. Alright, so pulling the inverter cover off is pretty simple. We'll tip our motor up this way first. And then it just has a bunch of these T30 screws around the periphery. Let me readjust you guys here real quick. And then actually, this connector here on the top has 4 little T10 Torx screws in it. Those like to strip out pretty easily, so you want to be real careful both when removing and reinstalling those. But let's go ahead and get this cover off real quick. So there's the inverter cover off, and we're real clean in here, no major signs of coolant intrusion or corrosion, so that's a really good sign. The big thing we want to avoid is coolant getting to the inverter. Alrighty, so now we've got to start taking apart the inverter components to actually get it off. So the first thing we have to do is we have to remove this kind of bus bar splitter assembly. So you've got your positive and negative input from the battery, and then these bus bars split it to each of these 3 phase switching units. So you've got positive and negative going to each of the terminals on the 3-phase driver components here in the inverter. So first thing I'm going to do is actually take these little tiny screws out here. On this particular style, which is used on all the RAV4s, and some of the very early Model S drive units. You've got to be real careful when taking these screws out, because it can twist off the, there's a little circuit board located underneath that's kind of a voltage sensing board, and it can twist off the actual little components on the board that these screws attach to. So you want to be real careful with them. Once it's broken loose, it's fine. But the actual getting it loosened without it twisting off is the tricky part. Okay, that part's done. And now I'm going to take out all the screws around the periphery that we have to take this bus bar assembly off. Depending on whether it's Model S or a RAV4 or a B-Class, there's kind of different ways to do it because they all have slightly different setups. On the RAV4 here, I'm going to remove the 2 screws on the plastic tabs here, and then on the bottom here, near where the connector is, I'm actually going to remove the 4 screws that are attached to this kind of V-shaped bracket, because the connector is attached to that and you can't actually access the screw because it's directly underneath this bus bar. Wonderful engineering choice there, of course. Alright, so now I'm switching to a T40 so we can take out the larger fasteners that are actually in the bus bars here. Alright, now I can take this thing off. It's got a couple connectors we need to unplug underneath it. And there we go. Alrighty, we've also got to unbolt our 3 phases here that are behind this cover. I actually already punched the holes through the sticker here, as you can see when I did the isolation check. But normally I would just punch holes right through with my T25 bit. One goes right on the thumb of the hand here, and then the other one goes right at the edge of that triangle. That's how I always find them. There we go. These right here are just some T50 fasteners. So go ahead and get those out real quick. So there's a couple more things we have to disconnect before we can pull the inverter off, and that's a little bit of this wiring. So we have this right here. That's a stator temperature. And then there's 2 coolant temperature sensors. So one is right here, you can actually see the sensor directly below it, just that short little wire. And then this one is actually located all the way on the other side. And it, along with the stator temperature wires, are zip tied to these ribs. So I'm going to cut all those zip ties off, unplug all these connectors, and then lay them off to the side so that they're out of the way. Alrighty, so the last step to get the inverter off is we have to remove the screws down in the center here. So there's a couple of screws on the corners. Those we want to leave in place. We just want to remove these 4 that are in a rectangle and then the 3 that are in a center. So we've got 12 that make up the 3 rectangles and then an additional 3 in the center. So a total of 15 of those T30 screws. Alrighty, let's go ahead and remove all these. Alrighty, so the inverter's ready to come off. I have at the ready here kind of a little block jig that the inverter can sit on top of, and then I'll actually screw it down to the block so that it can't fall off or anything once it's on there. So I've got all that stuff at the ready. We'll go ahead and kind of break the seal and then just pull that off. Set the inverter down on our block here. And there we go. Now it's got that screw in it. It's not super tight or anything, it's just on there so that it can't fall off or go anywhere. Go ahead and wrap up our wires here so they don't get in our way. And then we can go ahead and flip the drive unit back over to the other side. Alrighty, so we've got our drive unit flipped back over kind of at a 45-degree angle here. First thing we'll do is pull the side mount off, and then we'll unbolt everything for the end cap, and then we'll pull that end cap off. Alrighty, so now we can get ready to remove the end cap here. There's not really any easy way to separate it. This is just kind of, they use just a silicone gasket maker on everything on these. So there's not an easy way to separate it apart because there's really nowhere to pry against or anything. I've found that the easiest solution for me is to take a razor blade and try and pound it in right where the motor mount ears are on either one of them, whichever one I can get kind of the best purchase. Just kind of pound it in there to separate it just enough that I can get another tool in, like a screwdriver, and then I'll gradually work it up just enough that I can fit a bigger tool in there and then pry the thing up. So let's get that going. So I've got my hammer here. I think that this is as good a spot as any. We'll get that started in there, and then we'll just tap it in. There we go. So now I've got that spread apart just enough that I can take a thin screwdriver here and I'll wedge it under the other side. And now we've got enough of a gap that we can actually get some bigger screwdrivers in here. And then we'll just kind of slowly work this thing off. Obviously, you want to be careful not to mar up the sealing surface on here. Okay, that's off. And of course it also took our reluctor wheel off there as well. And there we go. You can see how nasty looking it was in there. Lots of rust and corrosion in the bottom. And of course you can see we've got the green corrosion on the rotor itself. And I'm sure once we get it out of there, there will be plenty of rust on the inside. And again, this thing is still locked up in there pretty solid. We can't spin it at all by hand. So there's just a couple more things we need to do real quick before I flip the motor over. First, I'm going to put kind of a retainer plate on here so that after we flip it over, the rotor can't land on our foot. Probably not going to happen on this one since it's seized in there, but definitely don't want crushed toes from a 60-pound rotor. That would be bad. So that's just there kind of as a safety. And then we've got to remove these 6 nuts that are on there's a couple of studs that stick out through the inside of the gearbox on the differential bearing retainer plate. So we'll go ahead and remove all those. Don't know if I can get to this one, but maybe. Yep, don't think so. Probably gonna have to take that one off with just a regular wrench. Alrighty, I think I can get in here just enough with this thing. Is that gonna work? Kind of. I guess I can get an actual ratchet in there, can't I? Just barely. Alrighty. Alrighty, so now we're going to get the gearbox apart. We have to take the gearbox apart to be able to get the rotor out because it's going to have to be pushed through from the other side. There's a couple differences between this and Model S. So the RAV4 and the Mercedes B-Class both have this parking pawl servo motor, as well as a mechanism with a linkage that goes all the way across to the primary drive. So we'll go ahead and pull this off, and then we'll remove all the bolts around the periphery, and then we can pull this case half off. Alrighty, I always find that the easiest way to get the case half here off is just to kind of give it a couple taps from the bottom side to break the seal, and then we should be able to just pull it apart. There we go. And there's our case half off. You can see it actually left behind one of our counter gear bearings. That tends to happen on later build LDUs like this one. So we'll go ahead and set that aside and we'll reinstall it back in the case. So now we've got to remove all the gears. First, I'm going to remove the oil pump drive gear, which is actually just a plastic gear. And it just has a little E-clip that holds it on. So there's our E-clip. And we should be able to just pop that thing loose. So there we go, plastic gear. And now we can remove the differential gear, which we already removed those nuts on the back side, so it should just pull straight out of here fairly easily. Just like so. And now for both the RAV4 and the B-Class, this part can be a little bit tricky because we have to remove the counter gear and the primary drive gear simultaneously because we don't want the gear teeth binding up on this parking pawl wheel from the counter gear, and we don't want, well, yeah, basically we don't want gear teeth binding up on things that they shouldn't be and causing damage. I've seen these get damaged before by either not installing them properly simultaneously and not removing them properly simultaneously. And it usually manifests as just a slight clunk every revolution of the counter gear. So we want to avoid that at all costs. There's a couple of bearing retainer plates underneath these. Each one just has 3 10mm bolts. Getting them out from under the counter gear is going to be pretty tricky because obviously, since the motor is seized, we can't spin this. So we might be able to try and get enough leverage on it where we might be able to get it to turn if we get some leverage on here. We don't need it to turn very much, just a little bit, so that we can get all the screws out. If we can't get it to turn, what I'll have to do is drill out, there's a kind of like a freeze plug with just a tiny little 1/8" hole in the center of it. That's down here in the counter gear, or sorry, in the primary drive gear. If worse comes to worse, we'll drill that out and then we'll be able to push from this side to get the rotor out using a long punch or something. So let's see if we can actually get this to spin just a little bit. So I've just got a big set of water pump pliers here. Let's see if I can get this to turn at all. Oh, I can. Okay, that's not too bad. So we'll get our first hole lined up. That's about right there. And our second one here is pretty close to lined up. We might have to rotate just a little bit more. Actually, no, we need to go back the other way. There we go. Let me fish those out with a magnet real quick. That one must still be in there, like one thread. There we go. There we go. There's the third one lined up. All right, and then there's just 3 right here on the primary drive gear as well. So the other thing I'm going to have to do is I'm going to have to remove the oil pump here, because the little spray nozzle on it is going to be in our way. And we'll just kind of get that out of there and sort of push it off to the side. We'll get our actual retainer plates out from underneath the gears here. And let's see how easy these gears are going to pull. So that one feels like it's in there pretty tight. And so does that one. So this is going to be a little bit of a tricky operation. This one I'm not so worried about damaging the bearing, because it's kind of always a default for me to replace the primary drive gear bearings. So I'll probably kind of do sort of some sharp pry motions to get that to pop up just a little bit, but I want to be more careful on the counter gear here. So I'm going to go and grab my gear puller, and we'll be able to gently pull the gear out of its bore there. All right, so what I always do for this little operation is I take just a long 3/8 drive 13mm socket, and I drop it in there to use as a spacer. We'll take the puller and drop it into position. Everything's good here. So there we go. Now we can pull very gently. And the thing that I'm watching for is I'm going to watch on the primary drive gear and make sure that I don't end up binding on the teeth. So right now, that's as far as I can go. I moved, I don't know, maybe 1/8 of an inch up. So next I'm going to take a pry bar and try and give the primary drive gear here just a little bit of a jolt, just to try and get it to pop loose a little bit. Not too hard. I don't know that we're getting much movement out of it there. There we go. And now we'll work the counter gear back up again. Again, we're going to go just as far as we can before the gear teeth contact. And hopefully this should move a little bit easier now. There we go, got it just a little bit. Same thing again. I think we're almost there. There we go. I think it's just about out of there. So go ahead and move that one up a little again. There we go. So that's broken free. Boom, and now they're both free. So we'll go ahead and pull them both out. And I'll go through and closely inspect the teeth here and make sure there's nothing damaged. Alrighty, so the next step is to try and get the rotor out. If I have to, I'll get this thing set up in the press and push it out. But that's, again, you know, a pretty tedious process to try and get this thing set up on there. So what I'm going to try and do is punch it out. And this one doesn't seem like it's too badly seized, so I think I can. So I'll just take a punch right in the center of the end of the shaft there. And I can actually see it moving there. We'll just go until it bottoms out on our safety strap down there. There we go. And it basically fell out right onto the safety strap. So now we'll flip this back around so that the motor's kind of horizontal, and we'll go ahead and pull the rotor the rest of the way out. Okay, go ahead and remove our strap. Now we should be able to just pull the rotor out. There we go. You can see kind of the crustiness on there. It doesn't take much to get these things to lock up, but it is enough on there to cause a problem. And it looks like our end rotor bearing is actually stuck in the case there, so we'll have to go ahead and pull that one out. Usually they come out with the rotor, but not always. Alrighty, so while we've got the whole thing apart here, we can actually test the isolation on the stator while it's isolated from everything else. So I've got my my mega ohmmeter here. We'll go ahead, I've got the negative lead just grounded out to the case. We'll go ahead and put our positive lead on one of the phases. Let's see what we get. Yeah, it looks like maybe about 20 mega ohms. It'll keep rising if I hold it there, but somewhere in that neighborhood. So that's actually kind of better than I thought it would be on its own. It's not the greatest. Usually on one that's really, really good, I would expect to see over 100 mega ohms of resistance. But that's still, you know, pretty serviceable, all considered. You know, sitting here apart, it'll kind of give it a chance to maybe dry out a little bit, and we'll clean out all that corrosion, and it might improve it even more. But I'd say we're in pretty decent shape there as far as isolation goes. We can go ahead and do it on all three phases, but they should all be basically the same because they're all essentially interconnected. And yeah, see, we get the same thing there. let that fully discharge. There we go. And then if we go to the third one, of course, we get basically the same result. So anyway, we're in pretty good shape there. We can start getting stuff cleaned up and take apart everything else that needs to be taken apart. We've got to take the bearings off of the primary drive gear, as well as the other primary drive gear bearing that's in the case half, and then we'll have to replace the 2 rotor bearings as well. And of course, this motor will get the rotor coolant delete manifold and all that good stuff. So my bearings are actually on order. They just apparently shipped out today, so hopefully, if I get really lucky, they might show up tomorrow, but probably the day after. So we'll pick up when I get the bearings back in. I think that I'm going to split this video up into 2 parts. So this is probably going to be the end of part 1, and we'll pick up again for part 2, where we work on getting all the stuff, bearings swapped out and put the thing back together, and then we'll get it back in the car and test drive it and everything. So anyways, thanks everyone for watching, and be sure to stay tuned for part 2.